The Southern Hemi swell pattern is improving, and the La Nina models are also improving. I'm Mark Sponsler from Stormsurf.com, and here's the surf forecast for the week starting Sunday, May 22nd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see remnants of a gale with still like 27-foot seas aimed off to the northeast, and the beginnings of yet another gale south of New Zealand, again with about 26-foot seas starting to develop and also aimed to the northeast. This is the beginning of a new and potentially better pattern. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough that is a dip in the jet actually pushing to the north. That helps create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And low pressure, if it's strong enough, of course, generates winds. Winds, as they get traction on the ocean surface, generate seas. As they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. All right, so it all starts with the trough, and clearly we have a decent, well-organized trough. New Zealand's right there, Antarctica, Ross Ice Shelf right down around here. So just southeast of New Zealand. Winds not particularly strong pushing up into it, maybe, about 110 knots, something like that. But then, as we go into Monday, the trough continues, and Tuesday, a little bit more wind energy, 140 knot winds start feeding the trough yet again. It builds, redevelops, starts pushing east, continues into Wednesday evening, if not even Thursday, getting a little bit of reinforcement, and then starts pinching off, getting smaller in coverage, and that doesn't do so well for supporting gale development. But this isn't until Friday evening, and then as we get into Saturday, well, it almost looks like maybe more reinforcements are on the way. Hard to say, and it's moving off towards the mid-central South Pacific, and then 180 hours out, maybe the Southeast Pacific is going to wake up, but it looks like the New Zealand area under there is going to be affected by a ridge, that is the jet stream pushing south. That only creates high pressure aloft and does nothing for supporting gale development. So the focus, a week from now, might start moving to the east. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, remnants of the first gale at, what is that, about 956 millibars, is fading in southeast of New Zealand, but a new fetch of 40-knot winds is building south of New Zealand. Forecast building to, 45 knots, there we go, just a little patch of 45-knot winds this evening, and then pushing east of New Zealand at about 30 to 40 knots, maybe 30 to 40 knots. Then another system, as we get into Monday night, early Tuesday, develops under New Zealand with 45, almost a little area of 50-knot winds, lifting pretty well to the northeast, targeting Hawaii and the U.S. West Coast and Tahiti and Central America and South America. So a pretty good run here looks possible. That gale starts fading on Wednesday and Thursday. Remnants, a little, maybe a secondary patch of 45-knot winds over a small area. Forecast Thursday night into almost Friday, and then we're looking out beyond that to see if anything develops off in the far southeast Pacific. We know a trough is forecast, but as of right now, it looks like 30 and 35 knot winds, but nothing up in the minimum threshold we really want to see, which is about 40 knots and preferably 45 knots. So something to keep your eyes on, but for right now, it looks like we're in pretty good shape. Now we're going back in time to Monday, almost a week ago. A tiny gale developed southeast of New Zealand, started building. It wasn't big, 30-foot seas, 28-foot seas, something like that, 27-foot seas into Tuesday, then finally got up to about 30, it says 35 feet, but we'll give it about 33 feet is probably functionally what it was on Wednesday, pushing out of the Southern California swell window on Thursday. Maybe a little secondary gale developed, but I don't know if really any meaningful swell will result from that. The net effect is probably nothing for Hawaii because this system was pretty much east of their swell window, but swell is expected into California later in the work week and a little bit earlier, of course, down into Central America and Peru and that area. But a little taste of swell starting. Then on, let's go back to Friday. Here we go. On Friday evening, the first in the series of gales started developing under New Zealand with 32-foot seas building to 33 feet, then barely up to 35 feet on Saturday, pushing off to the east and fading as of Sunday morning. And right now, this is where we're at currently. That was all confirmed sea height data from the models, hindcast data. Now we're going to the forecast looking forward. We already know there's one coming from that system that was in this, one swell coming from the one that was in the Central South Pacific, a second one from the system that was south of New Zealand on Friday. Here comes a third one, a small one though. This one just isn't forecast to have a whole lot of fetch and a whole lot going on with it, but certainly some backfill swell. And then on Tuesday, yet another system developed south of New Zealand with 34-foot seas building to 35 and 36 feet on Tuesday evening, continuing pushing off east of New Zealand, still on Wednesday evening, 30-foot seas, and then fading. So that's 3, if not 4 swells, all sort of back-to-back, all starting in the, we'll say for California, roughly on Thursday, and probably into Hawaii for the weekend, something like that. Anyway, a secondary small system, we know it's forecast on Friday, but look, just a tiny little area, 30-foot seas. And then we go into Sunday. We know something might try to develop again in the Southeast Pacific, but as you see, no real meaningful seas. You want to see at least 26-foot seas before you even really pay any interest. That would generate a 15-second period swell, and that's pretty much what it takes to radiate up into Hawaii and the U.S. West Coast to have any size. Otherwise, it's all just decayed away. All right, let's move on. Wind swell relative to Hawaii and the U.S. West Coast. There we go, California right there, Hawaii there. High pressure, 1028, 1030 millibars. Winds rotate clockwise around it. The high ridging into the U.S. West Coast, Northern California, with perpetual 25 to 30 knot winds and 48-degree water temperature from just non-stop upwelling, and then the fetch wrapping around the south side of the high, creating trade wind swell along east-facing shores of the Hawaiian Islands. That's as of right now. Monday, trade wind swell starts fading for Hawaii. The local fetch relative to California, if anything, only builds 30-knot north winds or northwest winds on Monday evening into Tuesday morning, but then notice right along the coast, a little bit of fading wind. Trades fall out for Hawaii. Let's get into Wednesday here. You see again the fetch in place over from Cape Mendocino south to about a point off of let's say San Francisco, but near shore, probably that eddy flow. You see the low pressure here. That sets up a southerly flow, the high pressure out here, the northerly flow. You get that eddy flow up along the coast there, 5-10 knot south winds. That's certainly better than raging north winds, and maybe would help to warm water temperatures a little bit and have conditions be a little bit cleaner for the resulting wind swell. But then as you get into Thursday, look, low pressure moving in, the high loses its ground, and literally the fetch just vaporizes, at least for a little bit. Low pressure, probably good, not really good enough to generate any swell, maybe some wind swell with luck, but mainly just rain for the Pacific Northwest. Nothing really into California other than maybe Cape Mendocino. But light winds continue along the coast thanks to the low until the low pushes inland. Then you can see the high trying to rebuild on Sunday. And here comes the north wind machine again, 20, 25 knots, all along north and central California. 180 hours out, just again, the water temperatures dropping, strong winds, and then these trades again start setting up for Hawaii, possibly making wind swell there. No precip of any meaningful kind, certainly in the snow variety expected for this year. Nothing there. But we are looking at snow levels, and we're talking about snow melt and what the deep snow level is for people backpacking in the Sierra. I mean, right now, the continuous snow level is somewhere around 8,000, maybe 8,300 feet, something like that. We've heard reports of going over passes that are 11,000 feet, that it's extremely treacherous. There's still a lot of snow and, just very mixed conditions. Probably don't want to be doing any high passes, but looking at where the freezing level is, so today about 12,000 feet, going to get quite warm here on the 24th, 25th of May, the freezing level above 14,000 feet, and then settling back down into about the 10 to 11,000 foot range out till about the end of the month, the 30th, and then the snow level back at 12,000 feet and heading up from there. So a steady melting of the snow at higher elevations is expected. Seasonally, that's about right, end of May, early June. But given the fact that we have had snow, it's been in spurts, but it hasn't been a epic snow year in terms of total snowfall. Yes, at Olympic Valley, they got exactly what they normally get. Water content in the snow quite low though, and the expectation is that the snow will start melting off pretty well as we get into mid-June. All right, let's go take a look long term. What's going on with the Madden Jullian Oscillation and the El Nino Southern Oscillation, or specifically La Nina, and what is its current state? Things are looking better. All right, so the first part of the long-term forecast is the examination of the MJO, the Madden Jullian Oscillation, that periodic oscillation that travels west to east around the planet on the equator, active phase and inactive phase. The active phase is the one we're interested in. It feeds energy to the jet stream. It's effectively a low-pressure system. When it pushes over the Pacific, it reduces trade winds. It imparts energy to the jet stream and can create Kelvin waves that are, in effect, a pool of warm water that travels under the equator from the West Pacific to the East Pacific. Successive medium to strong phases of the active phase of the MJO can help usher in or be a signal of the beginning of El Nino, which of course is great for storm and swell production. The other side, the other phase, so two sides on either side of the planet, active phase on one side, inactive phase on the other. They rotate around. The inactive phase does the exact opposite. It ushers in a high pressure or feeds high pressure over the Pacific. It steals energy from the jet stream and helps to suppress or mute storm production. So we're always looking for the active phase of the MJO. All right, and with that, let's go take a look at winds on the equator. This is the West Pacific here, East Pacific here. 0 is the equator. The date line is right there. California is at 120, but this is on the equator, so actually landmass goes even over to about 80. That would be Ecuador over there, 80 west. Okay, and over here, Philippines would be up somewhere in this region. That is New Guinea there. The Kelvin wave generation area, we call it, the area from 5 north, 5 south, from about 135 east out to about 170 west. Right in here, when the active phase moves over this area, trade winds fade, and this is where you can get Kelvin waves produced. All right, we're just looking at the arrows. These are 5-day average winds from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. The arrows are what we're looking at. The longer the arrow, the stronger the winds. So pretty strong winds in the East Pacific, pretty strong in the Central Pacific, and we'll call them modest to moderate over the Kelvin wave generation area. But it's not the actual wind speed, it's the difference from normal for this time of year. And you see, and it's the east-west difference. We don't care about north and south. Are they blowing stronger out of the east or stronger out of the west? Right here in the East Pacific, pretty much normal. No indication east or west. Same thing in the Central Pacific. Kelvin wave generation area, just slightly stronger out of the east, but not a particularly strong signal. So indicative of probably a neutral MJO or just weakly inactive. The forecast for the next week. East-west component of the wind. The blues are easterly anomalies. Think of that as the inactive phase. The yellows, reds, westerly anomalies, the active phase of the MJO. But let's get oriented. There's the date line right there. This is the whole planet. The Kelvin wave generation area on the equator 135 east, so right about there. This only right here is what we're interested in, from about 170 west to 135 east, Kelvin wave generation area. So according to this, easterly anomalies are in control pretty much as they have been since the last active phase of the MJO back. There's westerly anomalies in May, and even that was pretty weak. Maybe a little one also there in May. You see westerly anomalies moving from west to east. And now sort of a weak inactive phase, it looks like, and easterly anomalies holding for just the next 2 or 3 days. And then look at that, westerly anomalies again trying to make it to the date line for, we'll say, by about the 25th of May, something like that, and beyond. So a improving pattern, westerly anomalies slowly trying to get their way, trying to get a toehold into the Kelvin wave generation area. Let's go look a little further out. Okay, the MJO is like a low pressure system, the active phase. Low pressure generates clouds. Clouds prevent sunlight reflectivity off the ocean surface. That's what this model is, outgoing long wave radiation, sunlight bouncing off the ocean surface. The reds and yellows mean more sunlight bouncing off the ocean surface. High pressure, the inactive phase. Blues, if there were some, would be the active phase, exact opposite, more cloud cover. All right, let's get oriented. This goes out 2 weeks. A panel for each day, 4 different a panel for each 5-day period. Okay, Central America or South America, Central America, Hawaii, New Guinea, Kelvin dateline right there, equator right there, Kelvin wave generation area right there. So at this moment in time, maybe a very weak inactive phase, starting to fade 5 days from now, completely gone 10 days from now, then maybe trying to come back. This per the statistic model. Now the dynamic model says, well, we start out the same, but by about 10 days from now, the active phase of the MJO shows up and makes its way across the Pacific 2 weeks out. So that is the preferred option. A little deeper dive, same two models, statistic model here, dynamic model here, phase diagrams. I'm just drilling into about where the active phase is. How do you read the chart? Well, the active phase moves from west to east, from the Indian Ocean to the Maritime Continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot right there is where the active phase is. So we'll say moving over Africa, roughly. And there's 3 different projections here from the statistic model about where the active phase is going to go. This model says to the Indian Ocean. Oh, and if it's inside the circle, it's considered to be very, very weak. And that's pretty much what the statistic model is saying. The dynamic model, though, suggests that 1, 2, 3, 4, 5, 6, 7 days from now, a week from now, active phase starts moving into the West Pacific and building, we'll say, modest to moderately strong, and into the East Pacific, and then starting to exit the East Pacific 2 weeks from now. So clearly, this is the model that we want to see actually have happen. Let's take a look at the CFS model. This goes out a month. All right, same deal. Whole plan on one chart, the east-west component of the wind, the blues easterly anomalies, the inactive phase, the reds westerly anomalies, the active phase. Now actually, the solid black contour here are the active phases of the MJ. You can see one moving across here in late March. There was another weak one that tried to make some headway here in early part of May. It didn't do a whole lot. And then you just see looking out, there's really no MJO signal at all, a very weak MJO signal. So we're just looking at winds. Now notice back in February and March, strong easterly winds associated with La Nina were in control of the dateline region. And there's the dateline right there. The area we're interested in is right in this box here. But you see the depth of those blues getting lighter and lighter and lighter and lighter as we get into June. We're hoping that is an indication of the fading of the active, or the fading of the La Nina situation. This purple dotted contour here is actually, this is one flavor of the high pressure bias. We call it the La Nina signal. You see it just getting weaker and weaker and fading out like as of yesterday. That's on this one model we're looking at. This is the low pressure bias here. Now, this still shows it hold up in the Indian Ocean, not making any progress. But anyway, easterly anomalies slowly fading, but or I should say, and a bit of westerly anomalies trying to make it into the Kelvin wave generation area. Just a hint of the active phase of the MJO. This would be about June 4th, something like that. But probably maybe just a little bit of a nudge right in there, support for gale development, but clearly not a strong MJO signal, not a strong east-west anomaly pattern either. Nothing to really push the jet stream or feed or take energy from the jet stream. It seems like storm development is best when you're on the extremes. Hard La Nina, hard El Nino, but when you get into the middle area where there's neither El Nino nor La Nina, yes, you get storms. There's no influence one way or the other. You get just a sort of a typical normal type year, but often on the extremes, you can get some exceptional storms. All right, and then moving further out, the CFS model going out 3 months. Of course, we don't trust a model even 4 or 5 days out, much less 3 months out, but it's still fun to look. And sometimes you get just an idea of what's going on. And that's where we really want to talk about some improvements in the model here, and we'll get into that in just a second. But anyway, past performance on this model is on the bottom. The forecast is on the top. Right off the bat, here's the date line right there. Kelvin wave generation area, roughly in this area here, or looking forward up here. The thing you really notice is easterly anomalies on the date line, and as of right about in the next 2 or 3 days, they're supposed to start slipping off to the east and set up not on the date line anymore, but over the far east Pacific, with westerly anomalies slowly encroaching the whole way to the date line, maybe losing some ground 3 months from now, but taking control and having a good footprint in the West Pacific as we get into, well, August isn't even quite the early part of fall, but you get the general idea here. All right, we're going to overlay the MJO pattern. So, active phase, sort of this perpetual active phase that happened back in February and April. We're kind of in a weak inactive phase right now and sort of staying there, neither inactive nor active, and maybe a bit of an active phase building as we get into July and August, which would be great, but clearly an indication of no strong or significant MJO activity. But we're going to put the low pass filter on here. All right. Now the dotted contour here is the high pressure bias. You see it's had 2 contours. That's supposed to fade in July, and it doesn't really show it, but you see the east anomalies following. Well, here's the center of the high pressure bias, and east anomalies right in the center of it. Back when we were in this winter, they were actually over in the western portion of the high pressure bias. The solid contour is the low pressure bias. The leading edge of it, not really supposed to move, but westerly anomalies, well, that's at about 155, 160 east. So moving into filling about half the Kelvin wave generation area, maybe 60% of it. And also notice 2 contours instead of 1. 2 contours building in the low pressure bias starting in the latter part of July, whereas the high pressure bias is getting weaker. So theoretically, the demise of La Nina perhaps is indicated here. All right, let's go take a look down in the ocean now. We're done with the MJO. West Pacific here, East Pacific here. Data from the TA buoy array, that series of buoys on the equator. From 2 south to 2 north. All right, so these are the anchor lines on the buoys. The X's are sensors on the anchor lines. You use that data combined with a model to fill in the gaps, and you get a profile of where the warm water and cold water is in the Pacific. The 29-degree isotherm, much bigger than last week, making it almost to, well, we'll say to 168 east. The 28-degree isotherm almost making it to the dateline to 178 east, something like that. So both of these pushing off to the east some. The 26-degree isotherm at about 132, 133 west. I think that's about where it was last week. And of course, the 24-degree isotherm pushing on in. But suggesting warm water slowly, not like a Kelvin wave, but just in general, trying to backfill into the East Pacific, where previously much colder waters have been for 2 years. Now, it's not the actual temperatures, it's the anomalies, differences from normal from this time of year. The leading edge, there's a warm pocket here, a Kelvin wave, sort of a stationary, an area of warm water that wants to be a Kelvin wave. It just needs a strong active phase of the MJO moving over it with westerly anomalies to push this water off to the east. Now, this model actually suggests a steady, it actually shows a Kelvin wave impacting Ecuador. We don't think that is happening. There's no other data to support this. This model might be a little bit out to lunch here with a tiny area of cool water here. Now, there's another model right here that paints a little bit different picture. It's clearly lots of warm water, making it to, what's that, about 130, well, here, maybe we can just do it this way, 135 west. So a little bit of progress. We think this is a Kelvin wave. It's hard to say. It's moving so slowly. There is this other large area of cool water, which was much more intense a week, 2 weeks, 3 weeks ago. It's slowly leaching up to the surface, discharging, getting caught by the trades, dragging it off to the east. But we think some of that is, we're not sure whether it's the Kelvin wave pushing it or just the cool water going up sort of and the warm water is like backfilling into it, being sucked into it. Either way, warm water trying to move into the East Pacific. And that's important because warm water on the surface creates evaporation. Evaporation is rising air. That creates low pressure. Low pressure, of course, then feeds more warming in this area, and then that is how you get rid of La Nina. Then trades start fading, the sun starts warming the ocean surface, and then you get more warming, and it becomes a self-perpetuating cycle. Just like La Nina is the opposite. You have high pressure, which creates stronger trades, which creates upwelling, and the more upwelling you get, the colder the water that gets, the less clouds you have above it, you get downward falling air, and everything gets locked, and it just starts feeding the trades, and that's La Nina. We're trying to get out of that. We're trying to get the high pressure to break up, and we need warming, either by trades fading or by Kelvin waves erupting. Sea level anomalies. So let's get oriented here. South America, that's Chile, Peru, Central America there, Baja, California, Hawaii right there, Equator right there, dateline there, New Guinea there. All right, kind of hard to see the land masses. The point is, this chart is not temperatures. This is the height of the ocean surface, the sphere of the ocean. Is it higher or lower than normal? Cold water at depth contracts, creates a divot on the ocean surface. Warm water, like a Kelvin wave, expands, will create a bump on the ocean surface. So you see warm water, or actually positive anomalies, 5-10 centimeters above normal. Warm water here just north of the equator, that's about 3 degrees north, something like that. So certainly in the right area. And this bit of 5 centimeter anomalies here, negative cool water, is getting slowly weaker and weaker, and still the 10 and 15 centimeters over the Galapagos. Well, we think that is the origin point for upwelling, that cool water at depth that we saw. Right here, that cold water upwelling and discharging here in this area, okay? But slowly, little bit at a time, these anomalies are getting less negative and rising, meaning that the temperatures are warming subsurface here. So just more data to support what we were looking at before. Upper ocean heat anomalies for the Pacific. West Pacific here, East Pacific here, time going back a year. Kelvin wave in December pushed across the Pacific, impacted Ecuador. Then there was the upwelling phase, the Kelvin wave cycle. And you can see here clearly here, temperature, cooler temperatures, backtracking, getting less and less coverage back to like 115 west now, losing their intensity. Really, the only focus of the Galapagos are like right around here, and that's it. Warm water here, this Kelvin wave we were talking about, trying to push off to the east. A little pocket of it showing up here at about 145 west, suggesting, I mean, just you look at this pattern, you go, well, it sure seems like, if nothing else, the warm water is going to drag itself in to fill the vacuum as this cool water upwells to the surface. At least that's what it appears to be. Now here's where things start getting really interesting, and a little bit of what we were alluding to in the teaser up at the early part of this video. Okay, standard picture. The blues are cold water, colder than normal water. The reds, yellows, warmer than normal water. Chile, Peru, Central America, you get it. Equator, right around in here. All right. Now, clearly, La Nina in control, colder than normal temperatures off of Chile, Peru, the Galapagos there, the whole way out to the dateline and beyond. But, right here, last week, this was much deeper blue. The week before that, much deeper blue than that. 3 and 4 weeks ago, just a major upwelling pool of cool water. You see it's almost gone. Another week and this will probably be gone. We suspect, based on what we've seen in the previous images, that the pool, expansive pool of cold water at depth has pretty much all erupted. And now you can't see it here, but there is warm water making it to, well, where's 150? To about right here. At depth, there's warm water down below all this cold water, pushing this way, pushing the cold water to the surface, causing it to erupt, trying to make its way across the Pacific in the form of a Kelvin wave. We think that this might be, hopefully, the end of La Nina, or at least a significant weakening of La Nina, because the warmer these waters get, the less intense cooling that there's present, then that will help break down the high pressure above it, right? That will reduce trade winds, and then La Nina collapses. The next frame gives us even a little bit better feeling. Sea surface temperature trend over the past 7 days. So last week, I think there was a little bit of warming indicated. The reds are warming, but this week, warming off of Peru, warming off of Ecuador, the whole way across the equator, the whole way out to the dateline. Now, this isn't strong warming. It's not massively expansive warming, but it's not cooling. What it's suggesting is, just like what we're seeing here, is that temperatures are slowly warming in the ocean. The more they warm and the longer they warm, the better the odds that high pressure above it will start collapsing. And the backed off view again, it's just right here, that intense cooling, you see it. It's almost gone, almost indistinguishable from the other cool water elsewhere across the Pacific. That is a good sign. CDS Nino 1.2 index, basically sea surface temperature trend line, if you will. Today, 1.549 degrees below normal. Okay, and you can see this is where that big upwelling event happened in, we'll say, mid-April till about mid-May. Temperatures creeping up. They're not high. They're not really any higher than they were here, but we need it to get up. Well, the El Nino La Nina index, you got to get above ½ degree below normal for 5 consecutive months to become out of La Nina. Okay, we're not there yet. Okay, we're still a degree below, but this isn't the official El Nino monitoring region. This is here. Okay, temperatures, and this area runs from 120 west, so pretty much due south of California on the equator out to almost the dateline. Temperatures today, 802 thousandths of a degree below normal. Trending up some, just like what we've seen everywhere else, that the cool pool is fading, and in general, temperatures across the equatorial Pacific are trying to nudge their way up. Now, it's not even as warm as it was back in March or back in January, but we're heading in the right direction, we think, and you'll see why in a couple of minutes. So what does the atmosphere think is going on? I mean, we've gotten this sense that in the past couple of weeks, ocean temperatures are starting to warm. You know, the atmosphere doesn't react very quick. A week or two is like nothing in terms of the atmosphere. Temperatures in the ocean have to change significantly and be there for a month or 2 or 3 for the atmosphere to go, hey, look, something's changing here. Okay, and then and only then will the atmospheric currents start changing in kind. All right, but for right now, let's go take a look at what the atmosphere above the Pacific thinks is going on. It's called the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti's in the Pacific, Darwin roughly over the maritime continent, Indian Ocean sort of thing. When pressure is lower in Tahiti, the index goes negative. Well, today it's 9.06. And you just scroll back here, well, 24, 24, 40. It's been strongly positive for the past month. a lot of that, I think, is related to that cool upwelling event that's been going on off of Peru and over the Galapagos. The 30-day average takes some noise out of this because these numbers jump all around. 18.43. We peaked out at, what was it, about 20.34 here in May. And yeah, that was probably the highest it's been. This was higher than last year's high when we had La Nina, which was at about plus 19, and that was back in January. So we're starting to ease our way down, but not particularly quick. The 90-day average is even more of a lagging indicator. It's, let's see, 15.99 yesterday, today 15.96. Wouldn't be surprised to see this to continue to go up some, beating whatever the high was last year. It was at like plus 15, just right around plus 15. So this year's La Nina, atmospherically speaking, was stronger than last year's La Nina. But last year's La Nina peaked in January. We're in May, almost June, and it's only peaking now. So it's taken it a while to get there. Here's a 30-day average graphed out. You can see it pretty much last year's peak. Oh, 0 is right there. Anything above 0, if it's for any length of time, is La Nina, or at least these upward spikes are the inactive phase of the MJO. If you get successive strong inactive phases, that pushes you into La Nina territory. So here was our high, right about 20 last year in January. And then we kind of backed off last April, and now it's been a steady uphill climb. Again, the inactive phase has been stronger than the downward active phases. And here we are at, this index says 23, a little bit different than the other data we looked at, and starting to fall down. We need to get down here just to be neutral. The thing is, the atmosphere, I mean, how long can it sit in any one direction? There was a lot of talk about a third year of La Nina, so this coming fall and winter being another La Nina year, and this run-up sort of looks like that. But there's some other data that we're going to talk about now that maybe bodes a little bit better for us. All right, so we're moving out of the spring unpredictability barrier. That happens June 1st. And as we get closer and closer to that, this is from the Cfs Model, sea surface temperature anomaly forecast for the Nino 3.4 region, the official El Nino monitoring region. This model has been highly pessimistic. It's been the most pessimistic, depressing model of all the other models. Starting about, I think even last week, this model kind of came alive and said, hey, maybe things aren't going to be as bad as we thought. And multiple days in a row this week, the forecast has continued to improve. So this is the raw data, the most pessimistic of the most pessimistic model. And it shows, as of right now, temperatures are going to start moving upward to minus 1/4 degree as we get into July. Again, the La Nina threshold is a 1/2 degree below normal. Maybe we'll lose a little bit of ground as we get into fall, but according to this, temperature is only going to maybe minus 0.55 of degrees for a month, and then heading upward to dead neutral as we get into January. Now, this is the raw data. The corrected data right here suggests an even better pattern, moving to maybe 0.15 of a degree away from dead neutral in July, then falling down to right at the La Nina threshold in October and November, but not crossing it, and then back upwards after that. I mean, pretty much this is from the mid-June, July, August, September, October, November, December, January, all this is above the La Nina threshold, or at worst, right at it, suggesting a demise of La Nina. This is the first time in 2 years that we've seen anything that really strongly suggests that La Nina is maybe coming to a close. The CPC conglomeration or accumulation of all the models paints a very similar picture here. And so let's see if we can do this right. The reds, we'll do the blues. This is the Cpc Consolidated Forecast showing temperatures right at somewhere around the La Nina threshold from now, and then as we get into December, moving above it. So these are all the dynamic models. These are the statistic models. We can go here and look at the raw data from all the models. Here's the average of the dynamic models. The average of the statistic models, we're just going to go down to the average of everything. Here's the actual water temperatures. -6, -5, -6, right around that, just below the threshold, and then in December, peaking above it and heading up, looking very much like the CFS model. And the CFS model, let's see if I can even find it buried in here. It's a dynamic model, right? Oops, there, the light blue one, right here. Oops, where is it? Well, there you go. That, no, there we go. All right, anyway, what's showing here is actually not as warm as what we just saw in the other model. So this is stale data or older data. Like I'm saying, the CFS model is updating daily, and it tends to be the most conservative of all the models, and it's done actually a great job of sort of suggesting of where we're heading. And it now is saying that even this image that's showing here is probably biased cold, and that temperatures will actually warm above that. And here's the actual sea surface temperature anomaly forecast. I know these are really small, and we'll blow some of them up here, but here we go. Let's see if we can do this. All right, so there is the current situation, right? There's your big cold pool, and this is in June of 2002, or 2022. So we go to August, and all of a sudden, on the equator, sea surface temperatures are neutral, right there. -0.5 degree to -0.5 degree to +0.5 degree. So dead neutral with even a little warming over the Galapagos by August. And then you get into October and an even better situation. And by November, in the El Nino 3.4 region, or in the Nino 3.4 region, it's pretty much dead neutral temperatures. Now you do see cooling lingering, and that will have an effect on the atmosphere. But all this, if it's believable, from the most conservative of all the models, suggesting La Nina is dead or dying, and as we get into the early part of fall, it'll all be over. So, for right now, we got a pretty decent setup. There's small southern hemiswell in the water, radiating north towards California initially for the later part of the work week. And then 3 more systems behind that. One of them's already happened. The second one is just about over now. Third one developing in a day or so, and maybe more behind that. So a series of small, nothing epic, but rideable southern hemisurf, and Hawaii also getting in the action as well. So swell is on the way. But of more interest, at least to me, is the fact that the models, all of a sudden, the most conservative of the models is now literally in the past week or two, now that we're out of the spring unpredictability barrier, has woken up and says La Nina is going to die. Now, neutral water temperatures in October are pretty late in the game. The jet stream will take 3 to 4 months after that happens to kind of respond. So my guess is any improvements in the forecast, this winter probably won't be great. It'll still be a La Nina biased winter, probably better than last winter. I mean, at least there'll be, a bit more energy in the ocean, a bit stronger storms, improved chances for some precip into California. But as you get into late in the winter and the spring time frame, theoretically, and by springtime, I'm talking a year from now. That'd be 2023, like March of 2023. We could be in a pattern where things are feeling like normal, like it's over, maybe, and only 2 years, not 3 years of La Nina. Well, we'll just have to see. That's a long ways out, and, a lot of ifs, ands, and maybes in that forecast. But there is hope, for sure. All right, if you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the icon down there in the lower right. Comments always welcome. If you have questions, just write them up, and we'll be happy to answer to them. And other than that, go surfing, get some waves, go have some fun. We'll do this again next week. Same time, same channel. Thanks for watching.